This video is going to cover the topic of two-step hanger method. Be sure the date and topic are at the top of your page. The essential question that we need to answer is how can we use the hanger method with multiple steps to find the unknown value? And before we do anything else, I'm going to jot down a reminder of 3 key vocabulary terms. So the first 3 terms to remember are equation, which is of course showing that two values are equal and uses an equal sign. Variable, which is a letter that we use frequently in math to represent a value we don't yet know. And solution, which is a value that we could put in place of that variable that makes the equation true. So those are 3 reminders, but there are a few other important terms to know. One term is coefficient, and that's the number that's in front of a variable. So for example, if I have 5x, the 5 is known as my coefficient. And that means how many times I have a copy of that variable. So 5x really means the same as having 1, 2, 3, 4, 5 of those, right? And the coefficient there is 5. There's also something called a constant, and that's the number that's either added or subtracted from a variable. So like if we had x plus 9, this 9 is the constant, right? We would have added 9 on to whatever the variable was. And the last new term here today is inverse operation, and that's an operation that reverses or undoes another one. So if you add something on, the opposite of that would be to subtract it back off, right? Those are called inverse operations. Same with multiplying and dividing. Those are inverse as well. We can use inverse operations when we talk about what we call the hanger method. And the hanger method refers to the fact that we can see from this hanger that these two sides are balanced, and therefore we can infer that they both weigh the same. They must have the same value. So if this was x and this was 10, we would know that x was equal to 10, right? This one has x and 7 that is equal to or balanced with 16. So I'm going to write this equation here. And if I wanted to figure out what x was all by itself, I could take 7 off of this side and then take 7 off the other side so it would remain balanced. And I'm going to go ahead and write that down here as well. I'm going to take 7 off of one side and 7 off the other. And remember that adding and subtracting are inverse operations. So they're kind of undoing each other, right? They're adding together to make 0. So I would just be left with my x and 9. So the solution here would be x equals 9. This time I see that I have 2 x's balanced with an 8, and I'm going to go ahead and use my coefficient of 2 because I have 2 of them. 2 x's is balanced with 8. And if I want to figure out what 1x is worth, right, I'm going to have to divide these into 2 groups, right? So I have 1x on one group and 1x on the other, and I'll have to do the same thing here and divide this into 2 groups. So what we're actually doing is dividing this into 2 sections. I'm going to show that here. I'm going to do 2 divided by 2 so that I can have 1x by itself, and I'm going to have 8 divided into 2 sections so it can be 4. So my solution would be 4. And that might be pretty intuitive, right? Because you knew that half of the x's would equal half of that value of 8, right? If it's split evenly. We could also have a funny little hanger like this one where we see that kind of half of this x is balanced with 20. So we could say, well, x divided by 2 was equal to 20. And you'd have to think kind of inverse or think backwards to figure out what x must have been. And you might think, well, if this half was 20, if we had another half, that would be 20 as well. So x must have been 40. And if you're thinking about inversing, right, the opposite of dividing, I'm going to show this by multiplying by the opposite. Multiply by 2, and of course, we'd have to multiply the other side of our hanger by 2, and that would make 40. A little bit tricky on that one. We can also do these when we have equations that are slightly longer. So if you look at this equation, I have 3x plus 8 equals 14, and I want to make a hanger to show that both of these sides are balanced. And the first thing I want to remind you is that this 3 here is our coefficient. And so that means when I draw this, I have 3 of those x's. So I'd have to draw my x 3 times. There's also a constant of 8. I'm going to draw that in a circle here. And it's balanced on the other side with just plain old 14. And I'm going to think about how to figure out what just one x by itself would be worth. And so what we've done before is when we had added something on to our x, and we had that constant that was being added on, we were able to take it off, right? So I could take off 8 from this side so that it was gone, but I'd have to do the same thing here as well. And I'm actually going to write it below to show what I'm doing here. And so if we did that, we're left with 3 x's on the left-hand side, and on the other side, we are left with 6. So this has now become 6. And now I have 3 x's that I need to split 3 ways to be equal to 6. So I'm going to split those 3 x's up. I'm going to show that by dividing by 3 and leaving myself with just an x. And on the other side, I'll split my value of 6 into 3 groups. And 6 divided by 3 is 2. And that would be my solution. So if each of these was 2, that'd be 2, 4, 6, plus 8 would be 14. My solution would work. It's a little trickier when we have 2 steps, but it's totally doable. And we'll of course do another one. Let's go ahead and do, I'll change my variable this time. 2y plus 10 equals 60. So again, I have a coefficient to tell me how many y's I need. So when I'm drawing this, I'm going to go ahead and draw a y and another y, because I have 2 of them. But then I also have to draw that there's 10 on this side, because there's a constant of 10. And on the other side, it's just a big old 60. And I want to start the process of taking things off the hanger, right? I'm going to do some inverse operations here. And so I'm going to start by taking off this 10. So I'm going to subtract this 10 away, but then it'll start to tip unless I subtract 10 away on the other side. And I'm going to record that down here as well to show the math. And so I have 2 y's left on the remaining on the left. And if I do 60 minus 10, that becomes 50. And now I have my 2 y's that I want to split into 2 sections, right? Because I want 1 y to figure out how much just 1 y is worth. So I'm going to split that into 2 sections. So I just have 1 y. And I'll have to split my 50 into 2 sections as well. And 50 divided by 2 is 25. So that would be my solution. And I know that was just 2 quick examples, but I want you to go ahead and give this a try yourself. So I have the equation here, 3x plus 15 equals 27, and I want you to first draw it and then solve it, and we'll be able to see how we're doing with that. And remember that the essential question for this video was how we could use the hanger method with multiple steps, and of course we also reviewed some important vocabulary there as well.